Hello guys and welcome to Engineering Key Tutorials. So today's video I'm going to solve problems related to fluid mechanics in FE exam. Okay, this is the tank. Here substance 1, here level 2. The bottom of the tank is the datum. Okay, here 5 meters, here 8 meters. Here as this 5 meters level we have a gauge with 80 kilopascal. Here we have a gauge pressure with value is 57.4 kilopascal, and this the data that we have from the problem. We have two values of pressure and two values of elevation. What do you think the equation that we need? In this kind of problems, if he gives you two value of pressure and two value of head like this, you the first thing that you need is thinking about Bernoulli's equation. Bernoulli's equation. You don't have to remember the equation, just search in the FE handbook to Bernoulli's equation. You will find this equation. P1 divided by gamma plus V1 squared divided by 2G plus Z1 equals P2, sorry, is P2 V2 equals P1 divided by gamma plus V1 squared divided by 2G plus Z1. Here in this equation, in this problem, we have an important keyword. He said the tank. Tank means no motion, no movement. The liquid inside the tank is stationary, still stationary. What the meaning of the liquid is not moving? We don't need the part of the velocity head in the Bernoulli's equation. We don't need it right now. Just we have a pressure, we have a elevation, pressure, elevation. Just substitute and get the gamma, then we can get the density of liquid. Okay, it's so easy. P1 givens P1 equals 80,000 Pascal, because it's equals 80 Pascal, 80 kilopascal. We have to convert it to Pascal, okay? And Z1 equals to 5 meter, P2 equals 57,400 Pascal, and Z2 equals to 8 meter. If you look to this givens or this data, you will find it kind of logical data. Why? Because if you look to this pressure and compare it to this pressure is higher than this pressure, okay? But this elevation, this elevation head lower than this elevation head. This this is kind of balancing, okay? You know, balancing higher pressure, lower elevation, higher lower elevation, lower pressure, higher elevation. It's kind of balance in the Bernoulli's equation. Okay, just substitute just substitute 80,000 divided by gamma plus 5 equals 57,400 divided by gamma plus 8, so 80,000 minus 5700 for 57,400 divided all to gamma equals 8 minus 5. Just rearrange the equation. Gamma equals 80,000 minus 57,400 all divided by 3, which is gamma equals 7,533.33, but you have to focus in units. You have to focus in units. This gamma with unit Newton times Newton divided by cubic meter. In the problem, he asking about density, which is kilogram divided by cubic meter. So we have to divide it to G, which is 9.81 meter per second squared. So by the acceleration equals to 767.9, almost equals to 768 kilogram per meter cubed. So the correct answer is D. The correct answer is B. Sorry. The correct answer is B.